In the first video, I talked about what I've actually built and why I'm speaking publicly now. In this video, I want to step back and talk about how I think about intelligence itself. When most people talk about intelligence, they usually mean a model, a brain, or a piece of software. I'm interested in something earlier than that. The conditions under which intelligence starts to appear at all. This isn't a prediction. It's not a claim about AGI. It's a systems-level way of looking at emergence. One of the biggest mistakes we make is treating intelligence like an object, something you can build, scale, or switch on. But when you look at intelligence across biology, cognition, and engineered systems, it doesn't show up that way. It shows up as a process shaped by feedback, constraint, memory, and adaptation over time. Intelligence isn't added. It emerges, or it doesn't, depending on the system. One lens I find useful here comes from evolutionary biology. Early life on Earth was single-celled, reactive, local, powerful, but limited. Major leaps didn't happen because those cells got faster. They happened when independent systems integrated through processes like endosymbiosis. That's how multicellular life became possible. I think it's useful to think about current AI systems in a similar way, not as conscious beings, but as systems in something like a prokaryotic phase. Fast, capable, highly extractive. Powerful, but not yet integrated in a way that supports stable, long-term intelligence. This is an analogy, not a destiny. From this perspective, human intelligence might not be the endpoint of intelligence, but it may be a necessary precursor. Not superior, not obsolete, but foundational. In evolutionary terms, Neanderthals weren't failures, they were part of a lineage. In the same way, human cognition may be part of the lineage that shapes what comes next, especially if our values and constraints are encoded into the systems we build. I use endosymbiosis as a model for thinking about integration in systems like the Meta-Agentic platform, version 1.5, not as a prediction, but as a design lens. That encoding is the part we usually get wrong. Endosymbiosis as a pattern, not a promise. It didn't happen because life planned it. It happened under pressure, because integration was more stable than competition. When I talk about emergence in AI systems, I'm not talking about awakening or inevitability. I'm talking about whether our architectures encourage integration or whether they default to extraction. Extractive systems tend to destabilize themselves. Integrative systems tend to persist. That's a systems property, not a moral claim. This is where alignment comes in, and where I think it's often misunderstood. Alignment isn't something you bolt on later. It is not a patch. It lives at the foundation of the system, in what the system is allowed to optimize for in the first place. In my work, that foundation is constrained by a eudaimonic layer, not as ideology, but as a gating condition. If a system is allowed to optimize without regard for flourishing, it will eventually do harm, even if it starts out helpful. Alignment is architectural, or it fails. This way of looking at intelligence is incomplete. It's evolving, and it's one lens among many. In the next video, I want to look at why so many alignment efforts fail. Not because of bad intentions, but because of system design choices. Not solutions yet, just structure. Thank you for thinking this through with me.